those haven't submitted the list of group members, please do that. Please do so. So nanti there are three of you haven't, 3 or 4. So that I think the rest all already have 5 members. So I think that's fine. There's only one who has 2, and there are 4 students haven't given names. So I want that 6 students to be in one group. Only one group 6, the rest 5 of you. So the one that haven't submitted name, please submit other names so that I can identify and get you to be in the group of 6. And then I also want to remind you that next week you will have your test. So 20% only. 20% only. So if you don't prepare, then only just 20%. So just prepare, so you will cover everything discussed until today's lecture. Lecture 8. So later we discuss an example. So I provide sample of questions. So later on we discuss. I will not provide the answers. I mean we discuss the answer now, but I will not provide the written one. So let's discuss lecture 8 first. So this one quite not that. I mean, it's not just quite considerably or shorter than the previous lecture. So we have 2 topics: the specification error as well as the use of the what we call a test of non-nested hypothesis. Okay. So the test is open book. Next week the test is open book, but you are not allowed to discuss with your friend. So it is test. But it will. So you can refer to the all the materials. Lecture note, you can refer to lecture note. So please come early next week because it will be given in 2 parts. Part 1 is starting from 6:10 to 7:10 p.m. and then half an hour break, and then the remaining 1 hour for the second part. So if you come late, then I will not give you additional time. So you only have that until 6:10 p.m. for the first part. Alright, specification error. In constructing an economic model, the model should include key variables or core variables that's specified clearly. In this lecture, we consider several ways in which a model can be deficient, which we label specification error. So meaning that you use incorrect specification. Okay, for your model, they use incorrect specification on the model. Some of the major specification errors that our researcher may encounter in practice are, so there are 3 possibilities. The first one, omission of a relevant variable or important variable, but you did not include that important variable in your regression or in your economic model. So that what we call as omission of a relevant variable, whether one variable or more than one variable, so variable sum. Second, inclusion of unnecessary variable. So variable is not really relevant in explaining independent variable, but you include that variable in the model as an independent variable. So that what we call as inclusion of unnecessary variables. And then the last one is adopting the wrong functional form. So you're supposed to use double block model, for example, is better, but you use linear model, for example. Okay. So omission of a relevant variable for a variety of reasons. A researcher may omit one or more explanatory variables that should have been included in the model. As an example, consider the following model as the correct model. Let's say the correct model theory says that y depends on x1 and x2. There are two factors that determine value of y, but when you estimate, you only use x1 to estimate y. So there is another important variable you did not include. You do not include the model. So this is that's what we call as. So you excluding, or you did not include the x2. So the second regression model exclude the relevant variable x2. So as implication consequences by referring to the given example, the estimated coefficient in the incorrect model are biased. That is, their average or expected value do not coincide with true values. So meaning that the average of the average of possible estimate for the second model will not give you the true parameter that representing the effects of x1 on y. Okay, so with the incorrect estimate, you will not get the average, even though you take many example and you take average, it won't give you the estimate which is represent the true value of the effects of x1 on y. Okay, you use incorrect. You exclude the important variable x2 from the model. Okay. So the error variance estimated from the incorrect model is a biased estimator of the true variance. As a result, the usual confidence intervals and testing procedure are unreliable. And then the second possible error is inclusion of irrelevant variable. So this one not as serious as this one. This is more serious, not omission and variable. So if you did not include important variable, this is quite serious because it make your estimate to be biased. Okay, meaning that it will not give you the correct estimate, the correct effects of x on y. But second one, inclusion. So irrelevant variable. I mean this one. Interval estimate is not as serious as the previous one, this one, but it gives you, it still has some influence, some effect. It makes your estimate to be that not that accurate. Okay. Sometimes researcher include all sorts of variables in the model, whether or not they are theoretically detected. Suppose that the correct model is this one, so meaning that correct model only has x1, but you include additional variable which is not really important to explain the dependent variable. So you include additional variable. However, we add the what we call superfluous or not required variable x2 and estimate the following model. So instead of only x1, you include x2 as well. So as consequences, the estimated coefficient from the incorrect model are inefficient. Their variances will be generally larger than those of the estimated coefficient than the true or correct model. And as a result, the confidence intervals based on the standard errors of estimated coefficient will be larger than those based on the standard error or estimated coefficient of the true model. What will happen is that the true coefficient will not be estimated as precisely as we had used the correct model. Only the square estimated are not best linear. So estimators mean that if effects, it make the sampling distribution to be larger. So the possibility of you getting the true value is less because it's possible. There's possibility that you get your estimate is far from the true value, although it is still unbiased, but the chance for you to get more accurate estimate has been reduced. And then incorrect functional form, consider the following two specifications on the model. So here we have linear model, the first one, and